Now we'll move on to the second problem. A fair coin is tossed thrice. The random variables x and y are defined as follows: x is equal to 0 or 1, according as head or tail occurs on the first toss. I repeat, a fair coin is tossed thrice. The random variable x and y are defined as follows: x takes the value 0 and 1 according to as head or tail. When head occurs, we have to take x as 0 on the first toss, and when tail occurs on the first toss, we have to take x is equal to 1. That is what the meaning of the question. Y is equal to number of heads. So y represents number of heads. The question is, determine the distribution of x and y, determine the joint distribution of x and y, obtain the expectation of x and y and xy, also the standard deviation of x and y, compute covariance and correlation of x and y. So here in the previous question, joint distribution as given, whereas here we need to find out what is the joint distribution of x and y by using this condition. So the condition is given as x is equal to 0 and 1 according to head or tail when a fair coin is tossed thrice, and y represents number of heads. So let us see the solution now. For the given random experiment, the sample space is S is equal to, the sample space is S is equal to H, that is the when the coin is tossed three times, that is thrice, that is what given in the question. When a coin is tossed three times, the possible outcomes are H, 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 T, H, T, H, H, T, 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 H, H, T, H, T, 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 H, T, T, T. These are the possible outcomes when a coin tossed thrice. Now the sample space contains 8 outcomes. So here there is 8 possibility, so 8 outcomes. And the probability of each occurrence of these outcomes are 1 by 8. Among these outcomes, H appears in the first toss are in 4 in numbers. So you can see here H comes in the first toss. Here this is the first toss, here first toss, this is first toss, and this is first 4 in numbers. Similarly, T occurs in the first toss in 4 in numbers. For the outcomes x is equal to 0 and for the outcomes x is equal to 1. So let us put this on the table together. The sample space S and the association of random variable x and y is given by following following table. And that is, S represents the possible outcomes, number of outcomes when a coin is tossed thrice, and X represent 0 and 1. So 0 for when H occurs in the first toss, and 1 for when T occurs in the first toss. So that is what here x is equal to 0 and x is equal to 1. And Y takes the value Y, here you can see that in the question, Y takes the number of heads. Y takes the number of heads. So therefore here we have to see that how many number of heads in the first sample. So here 3 head, in this case 2 head, in this case 2 head, in this case 1 head, in this case 2 head, in this case 1 head, in this case 1 head, and whereas here it is there is no head, therefore it is 0. Here y represents the number of heads and x represents, it is given in the question that x takes the value 0 and 1, and we take 0 uh, uh, for h when a coin is tossed thrice, in the first toss h comes, and whereas here when a coin is tossed, in the first toss p comes. So this is the sample space which is associated with the random variable x and y. So from this is clear, we can find out what is the x distribution, what is y distribution, and we can find the joint probability distribution table. Now let us move on to the to find x distribution and y distribution. So in the first case, the probability distribution of x and y as follows. So x takes the value 0 and 1, whereas y takes the value here. X takes the value 0 and 1. X takes the value 0 and 1, whereas y takes the values. So what are the values y takes? So we start with the 0 first value, let me write it as 0. Next value 1 we are taking, 1 we are taking. Next value 2 we are taking, and 3 we are taking. So y takes here 0, 1, 2, 3, and x takes the value 0 and 1. Now let us find out the probability of x is equal to 0, probability of x is equal to 1 for x distribution. So probability of x is equal to 0. So when x is equal to 0, how many times x comes as 0? So you can see in the table here, x takes here, this is 1, 2, 3, 4. So here the possible outcomes when x is equal to 0 is 4. Out of total outcomes is 8. So therefore probability of x is equal to 0. Probability of x takes the value 0 is equal to, that is 4 by 8. That is possible outcome is 4, and the total outcome is 8. Therefore it is 4 by 8, that is equal to 1 by 2. Now x takes, similarly for x distribution we have to take probability of x is equal to 1. X takes the value 1. Probability of x is equal to 1. So here this is one value, 1, 2, 3, and 4. So x takes 4 values. So the probability of x takes 1 is equal to 4 by total outcome is 8. So that is equal to 1 by 2. So this is for the x probability distribution for x. Now similarly we go for y. So when probability of y is equal to p of y is equal to 0. So p of y is equal to 0 how many times? 1 times out of 8 possibilities. So therefore probability is 1 by 8. Now y is equal p of y is equal to 1. So p of y is equal to 1. So I'll move to the next slide. It is already written here. So p of y is equal to 0. So y is equal to 0 means how many times 0 occurs in 1 time. So therefore probability is 1 by 8. Total outcome is 8. Now p of y is equal to 1. P of y is equal to 1. So here 1, 2, and 3. So 1 occurs 3 times. So out of 8 total outcomes. So therefore probability of 1 is equal to 3 by 8. Now move on to P of y is equal to 2. P of y is equal to 2 how many times? 1, 2, and 3. So therefore probability of y is equal to 2 occurs 3 by 8. Total outcome is 8. Now P of y is equal to 3. 3 occurs only once out of 8 possibilities. So therefore P of y is equal to 3 is equal to 1 by 8. So we got the x distribution and we got y distribution. Now we can write the distribution for x is given by, when x is equal to 0, f of x is equal to 1 by 2. When x is equal to 1, f of x is equal to 1 by 2. The distribution of y is given by y. Y takes the value 0, 1, 2, 3, and f of y is equal to 1 by 8, 3 by 8, 3 by 8, 1 by 8. So this is about x distribution and y distribution. Now we compute joint probability distribution. Now we compute joint probability distribution of x and y. That is, by computing jij is equal to p of x takes the value xi, x takes the value xi, and y takes the value yi. And now x1, x takes the value 0 and 1. We have given the x value as a 0, and this is 0 and 1. So let me take, this is my x1 is equal to 0 and x2 is equal to 1, and y takes the value 0, 1, 2, 3, and I name it as y1 is equal to 0, y2 is equal to 1, y3 is equal to 2, and y4 is equal to 3. Now we'll find out first value according to our joint distribution. X takes the column value, y takes the row value, and x1 into y1 gives j11 value. So let me move on the next slide. So here the joint distribution of x and y is found as follows. So let me take first value j11. So how to get j11? When p of x is equal to 0 and y is equal to 0. P of x is equal to 0 and y is equal to 0 together. When x is 0, y is 3. When y is 0, x is 1. So when x is 0, y is 0, there is no possibility of outcomes here. So therefore that is equal to 0. j11 is 0. Now come to j12, that is the second value in the distribution, joint distribution. j12 is equal to p of x is equal to 0. So when I draw the joint distribution, if you want to make clarification, so here if I take, this is my x values, this is my x values, and here I have to take, this is my y values. So this is first y1 value, and this is my x1 value, and here it comes j11, and the next value comes j12, j12, j13, and so on. So here it is y2. So j11 we can get x1, y1. So when x is equal to 0, y is equal to 0. So therefore this is 0. Now j12, p of x is equal to 0, y is equal to 1. Let me move to the x is equal to 0, x is equal to 0 here, and y is equal to 1. So this is one possible cases. X is equal to 0 and y is equal to 1. So out of this must be 1, 1 times out of 8 possibilities. So this is 1 by 8. It must be 1 by 8. Okay. Now let us move on to j13. So the next value is j13. P of x is equal to 0, y is equal to 2. That is y3. Y3 we have taken as 2. So x is equal to 0, y is equal to 2. X is equal to 0, y is equal to 2. So this is 1 time, 2 time, x is equal to 0 and y is equal to 2. That is 2 twice it occurs out of 8 possibilities. Therefore probability of this is 2 by 8, that is 1 by 4. Similarly we can go for next value is j14, j12. Here j13 we have done, that is j13, y3, and for y4 we find out j14 till the y values. So y value till we have taken y4. So y4 is 3. Now when x is equal to 0, x comes the same value, x is 0, y is equal to 3. Now let me move back. x is equal to 0, y is equal to 3 appears one time. Therefore, the probability is 1 by 8. Now let us move to the second value in x, that is 1, x2. When x is equal to 1, that comes j21, j11 is done. Now next second row, I'll move to second row, that is j21, j22, j22, j23, j24, and so on. Now j21, how to get j21? P of x is equal to 1 and y is equal to 0. First value of y is 0. So x is equal to 1, y is 0. That is, I'll move to back again. Uh, I want x is equal to, I want x is equal to 1, y is equal to 0. So x is equal to 1 and y is equal to 0 is one possible cases out of 8 possibilities. So therefore, that is 1 by 8. This is 1 by 8. Now next value is j22. How to get j22? x2 is same, x2 is, x value is same, that is 1. Whereas y value, move on to the next value, that is y value is 1. Y, this is 0, this is 1 have taken, this is 2 have taken, this is 3 have taken. Y is a 1. So therefore here x is equal to 1, y is equal to 1. I'll move to next. Here x is equal to 1, y is equal to 1 time. X is equal to 1, y is equal to 1 or 2 times. So therefore 2 times out of 8 total outcomes. Here j22 is 2 by 8. Now let me move to j23. Next value is j23. X value is same, y value is changing, that is y is 2 here. X is equal to 1 and y is equal to 2. X is equal to 1 and y is equal to 2. So only once it appears, therefore probability is 1 by 8. Next last value is j24. This is j24. X values take, x takes same value, whereas y takes the next value, that is 3. X is equal to 1, y is equal to 3. I'll move to the sample space. X is equal to 1 and y is equal to 3. There is no possibility of that case, so therefore probability is 0. Hence these values we can prepare in the table and we write the joint distribution. This is x represent 0 and 1, y represents, we start with 0, 1, then 2, 3. It is not possible to write 0, 1, 2, 3. Now we can fill the table according to the values we obtained, and that gives the joint probability distribution for the given problem. That is, here this is 0, this is 1 by 8, and this is 1 by 4, this is 1 by 8. Whereas here when x is equal to 1, the value is 1 by 8, this is 2 by 8, here 1 by 8, and this is 0. So this is the required joint distribution. Now the next question is asked in the same problem is find the expectation of x. And already we are familiar about the formula that expectation of x is nothing but mu x, and the formula is summation xi into f of xi, where I takes the value 1 to, I takes the value 1 to 0 to 1. So xi is 0 and f of xi is 1 by 2. Xi is 1, f of xi is 1 by 2 from the x distribution table. I'm not going back. Hope it is clear for you. Already we got the x distribution table which takes the value x is equal to, this is x value, this is 0 and 1, and here it is f of x value, we got it as 1 by 2 and this is 1 by 2. So 0 into 1 by 2, that is 0, 1 into 1 by 2, it is 1, so therefore it is 1 by 2.
Expectation of x is 1 by 2. Now let me move on to a expectation of y, that is mu y. Formula is, this is for y distribution. Summation yj into g of yj. So we can see the y distribution table and we can find the data. 0 into 1 by 8 plus 1 into 3 by 8 plus 2 into 3 by 8 plus 3 into 1 by 8. From the y distribution table, calculating this, we get 3 by 2. Now expectation of xy. What is the formula to find expectation of xy? That is summation of xi yj jij. This is in distribution table. Xi yj jij. So xi, this value, this into this into this. So 0 into 0, next 0 into 1 plus 1 by 8. Obviously it is 0. 0 into 2, again 0. 0 into 3, again 0. Therefore, this is what written, first 4 value. X is equal to 0. We get the value is 0. Now, when x is equal to 1, xi into here, 1 into this is a 0. Therefore, obviously the first value is 0. 1 into 0 into 1 by 8. Next, I'll move to 1 into 1 into 2 by 8. 1 into 1 into 2 by 8 is nothing but 1 by 4, plus 1 into 2 into 1 by 8, and the last value is here 1 into 3, whereas this value is 0, therefore that is the last value, it is written as 0. So on calculating this, we get E of expectation of xy is equal to 1 by 2. Now to find the covariance and correlation, we need standard deviation of x and standard deviation of y. So let us find standard deviation of x and y. So that is sigma x square is equal to standard deviation of x distribution is equal to e of x square minus e of x whole square. This is what the formula. And e of x is already we got, that is mu x. We got the value for that, and e of x square we have to find. To find e of x square, we use the formula, already we are familiar this. In the previous problem, we used this formula. Summation xi square into f of xi. So, in the x distribution, take square and multiply with f of xy. That is x1 square into f of x1 plus x2 square into f of x2. That is 0 square into 1 by 2 plus 1 square into 1 by 2. That is equal to 1 by 2. Therefore, on substituting this, we get sigma x square is equal to 1 by 4, and therefore here itself we can write what is sigma x. Sigma x is equal to square root of 1 by 4, that is equal to 1 by 2. Sigma x is 1 by 2. Now we can find out sigma y square, that is standard deviation for y distribution. Formula is ey square minus ey whole square. Ey square is summation yj square into g of yj. So here we have to take y distributions. 0 square into 1 by 8 plus 1 square into 3 by 8 plus 2 square into 3 by 8. Next, this is, it must be 3 square. 3 square into 1 by 8. So that is equal to, on calculation, we can compute this and we get this is 3. Now substituting, sigma y square is equal to, on substitution, sigma y square is equal to e of y square is 3. E of y, that is mu y, already we got 3 by 2 whole square, and we get sigma y square is equal to 3 by 4. Therefore, sigma y is equal to square root of 3 divided by 4. So that is root 3 by 2. That is standard deviation of x and standard deviation of y. This is standard deviation for x distribution, standard deviation for y distribution. Now we'll find out covariance of xy. Covariance of xy is equal to e of xy minus e of x into e of x into e of y. This is what the formula, where e of x and e of x into e of y. This is expectation of x and expectation of y, already we got. This is expectation of xy, that is in the previous calculation we got the value expectation of xy. Substituting, and we get covariance of xy is equal to minus 1 by 4. E of xy is 1 by 2 and e of x is 1 by 2, e of y is 3 by 2, that is equal to 1 by 2 into 3. 1 into 3 it is 3, 2 into 2 4, 1 by 2 minus 3 by 4, that is equal to minus 1 by 4. Now correlation of x and y. The formula is covariance of x y divided by standard deviation of x distribution into standard deviation for y distribution. That is covariance of x y we got in the previous this minus 1 by 4, substituting 1 by 4, and standard deviation of x is standard deviation of x is 1 by 2, standard deviation for y distribution is root 3 by 2. On simplifying this, 1 into root 3, 2 into 2 it is 4, minus 1 by 4 divided by root 3 by 4. Therefore 4 and 4 gets cancelled, we get minus 1 by root 3. So this is about core correlation of x and y.